First of all, let me thank Mr. Balakakis and the organizing committee for this honorary invitation. Ladies and gentlemen, yes, my presentation is quite technical, so I'm going to try to make it as understandable as possible. I want to look at the key messages of circular economy, at the development of biorefineries and the good use, optimal use of raw materials. Here we have a graph that I've been showing over 20 years. It has to do with the historical evolution of the use of raw materials, especially minerals, mineral fuels, and their products. As you can see, we started off with wood, and we went to oil, moving through coal. This transition was always targeting moving from worst raw material to better raw material. For the first time, we're moving from the best raw material to the worst as concerns processing. What does that mean? And we need to see that in conjunction with the reasons why this transition is important. And we could very beautifully explain the need for that transition with this graph, which shows the McKinsey commodity price index in the years 1999-2001. And you see that over the 20th century, there was a constant downward trend, despite the fact that we had financial breakdowns and meltdowns, world wars, and this decline in the price index, the commodity price index, was not impeded. Why was this achieved? Because of oil refinement. The technology that allowed for better oil refinement also provided us with the opportunity to produce chemicals, products, fuels at a much lower production cost. The reasons that I'm describing at the right column led to a great increase of this commodity price index in the early 21st century. And the reason was that we had high fluctuations, a great accrued instability. We had developing countries where a large part of the population, such as China, is now part of the consuming public, which means that there is an increase in the demand for products incomparable to what we had in the past. And another thing is that the technologies we are using today are outdated, which means that demand at some point will override production, and this is when the global economy will collapse, which makes it all the more obvious why it is an urgent, dire need to move from oil-based production to circular production or bio-based production. Oil-based production, what did they achieve? They managed to produce fuels as well as all products and commodities that we're using today, either as chemical compounds that are transformed into end products or in the form of plastics. And they did that by producing 7 chemical compounds, out of which we have the production of the first products that lead to the end products that we consume today. All the various ethylenes, of course, are included here. And now we need to go from biomass to create sugars. In order to do that, we need intermediate chemical compounds that can be either produced using agri-food processes or using green procedures, which no longer depend on traditional industrial procedures such as the use of solvents that are hazardous to the environment. We could also have a combination of green microbic processes and chemical processes. This is a problem pertaining to the transition. It raises many concerns. We don't have the specialized staff that industries require in order to implement new technologies, these new technologies. And these are all high scale, meaning high economy scale procedures, which means that we need to start by creating chemical procedures that will fall under the new requirements. And the supply chain for gathering raw materials here is non-existent, which means that the end products produced will need to be better and more affordable than the traditional ones in order to replace traditional products, because we cannot convince consumers to use innovative products if they are more expensive than the traditional ones. And these are all side aspects of the problems that I'm trying to describe. Lately, our society has grown used to hearing the terms circular economy, but it's very difficult for us to realize and comprehend truly how costly this transition and problematic it really is. And now we're looking at the supply, production and consumption chains and how they produce waste. So I want to describe to you how the food consumption chain leads to bigger increased waste, which means that we used to have oil refineries. Now we need biorefineries. We need to transit from oil-based industries to industries producing products including food biologically and producing products that can be used for the production of chemicals, energy and plastics in a more green way. Here you see the various stages in the food chain, nutritional chains. You see farming residues, food processing, end of life after food is consumed, where they become trash. Food products are discarded as trash. And you see how in different stages of these chains, we have a production of different percentages of huge quantities of waste on an annual basis. This means that we are faced with an environmental challenge with a social dimension, but instead of looking at managing waste, we need to see how we can capitalize on waste. This is no longer a waste. We're talking about bioeconomy, so we need to have this utilized as a substitute to oil and other resources. So we need to think out of the box. We need to stop thinking conventionally. We cannot solve a problem with the same methodology that we used to create that problem. And this is why I want to describe biorefineries to you. The role they will have will be to fragment biomass. What does that mean? We break down biomass in different fragments with containing different components that can be used for different uses. First of all, I will describe as simply as I can what a biorefinery is, and then I will mention a few examples. Here, for example, we have waste from wine refineries, organic waste, solid waste, anything that is produced by a chain, a production and consumption, a food production and consumption chain. And we have a breakdown into fragments. And I will show them later on. Lipids, proteins, vitamins, bioreactive components that can be used to create side products We've got the hydrocarbons that are used, and we can use brewing, which is a biological procedure to produce end products. We can separate products produced and then move on to produce the end products. That can be biopolymers, they can be microbial oils, carotenoids, bacterial citrin, chemical compounds that will allow us to move on to chemical products. And fermentation is going to be a procedure which is going to be highly implemented here. What we're trying to do in my university is develop technologies in conjunction, in tandem with different scientific sectors that will allow us to create products in a circular economy way, so as to be able to see how these products can be introduced either within an industry or a sector or a chain of production. As everybody knows that there's lots of residues with respect to coffee. We're all drinking coffee, and this has lots of waste. We've got waste from juice making, we've got waste from pastry, from the pastry making industry, side products from industrial sugar, side products from breweries, and so on and so forth. And they can provide us with proteins, which can be used as animal feed. If they come from the right source, they can also be used, meaning industrial breweries, they can also be used for human foods. We can have oils or oily substances that can be used in a huge number of areas, such as biofuels. We've got antioxidants and we've got pectins, and they can also be utilized not just in food production, but also in food packaging. Through fermentation, we can produce vials. For example, 2,3 Vita vial can be used in many ways. We've got lactic acid, we've got electric acid, we've got many compounds that can be produced. For example, multilactic acid, PLA, you've heard of it. Polylactic acid. It's something that is utilized in many supermarket bags. The polyhydroxy PHP can be a substitute for propylene, parapropylene, in order to create solid packaging, which is packaging utilized as food packaging. One of the projects that we undertook, and it was concluded last year, it was financed by the Horizon within the framework of scientific research, looked into the organic fragment of urban solid waste in order to produce end products of added value. We had we have oily substances and oils that could be biogenic surface acting substances. They could provide us with such substances, and these are used either as enzymes or as in industrial applications. We've got a great part of those used in detergents, and just think about the use of detergents we make in everyday life. Another thing that can be subtracted from organic solid waste is proteins and pectins. We can have, as I mentioned before, the lacturonic acid that can be used for the production of polyurethane, and this is one of the most important insulation materials used in construction. So we see how many products can be derived from waste, and it is possible to derive those products. And here I'm showcasing another example. In this particular example, we have been using different types of waste from pastry making industries, from bakeries, with side products of wheat, ground wheat, grinding, and we've got different products included like citrus, even fruits, citrus fruits can be part, and we come up with pectin, one of the most important polysaccharides, which are the foundation for the structure of biomass, of cytic biomass. We've got lignin, we've got biocitrin, and that allows us to produce clear citrin, and this is one of the most important products for industrial production, and it's going to be a foundation for the circular economy. Why is it so important? First of all, we can produce nanocitrin. Which is another name for nanocellulose. And another thing that I'm showing here, a product that we can produce in the laboratory very easily, biodegradable, edible films. Whenever you see in the supermarket films covering, for example, fruits and vegetables, we could replace those plastic films with biofilms. So these cellulose-based, edible, biodegradable films. This is not a research project, it's direct funding to us in order to create a technology that will start with microalgae. This is a Greek interest-led company coming to us from the States and Canada. They are interested in producing polymers that will lead us to producing packaging bottles, for example, that will be biodegradable. You see how here packaging amounts for the majority, food packaging has the largest part to play in the overall packaging pie. If we manage to produce this biodegradable bottle, we will be able to use these added value products to cover meat for all losses that will be obtained by stopping conventional bottles production. Now, this is another slide that I wanted to show that has to do with how production is being conducted nowadays, and this is how it's going to be in the future. And this is why we call this slide the principles of circular bioeconomy. We will have recycling at the end. The ideal type to recycle is chemical recycling, meaning that we take in the polymer, fragment it into its constituents, and therefore have a perennial, so to speak, recycling of these ingredients in order to minimize the need to use resources, fresh resources. And what does that allow technical economies? It allows them to become independent. For the first time, sustainability acquires a competitiveness, a very strong competitiveness angle, as well as an angle of national independence as regards raw material production. Thank you very much for your attention.